Okay, moving forward about half projectile motion in case of an electric field. Let's say I had an electron traveling with a speed of 6 into 10 to the power of 7 meter per second, right? And the entire vertical distance was provided to you as 2.2 centimeter and the horizontal distance is provided to you as 12 centimeter. Initially, they ask you, by the way, before we move on, please understand that as the electron moves into the electric field, it will experience a force that will cause it to deflect. Electron is a negative charge particle, so it will be attracted downwards towards the positive plate. Right? In half projectile motion, just a quick revision, there is acceleration in the vertical plane. In the horizontal plane, there is no acceleration. So calculate the electric field strength, they ask you. So it's a uniform electric field. You have the voltage values, E is equals to V upon D, and you get the electric field strength. They ask you calculate the force on the electron. F is equals to EQ, you get the force. You have the charge of the electron from the data booklet. You have the electric field strength from the previous part, and you get the force. Then they can ask you for the acceleration. F is equals to ma. Please note that the acceleration value is this. Compare it with the gravitational acceleration, which is 9.81 meter per second squared. Don't you think this value is extremely large when compared with the gravitational acceleration, right? So the force of electric field is extremely large simply because of the fact that its acceleration is large. So throughout electricity, we will ignore the gravitational effects. Moving forward, they will ask you to calculate the time taken for this electron to travel 12 centimeter. Now 12 centimeter was the horizontal distance. Horizontal distance, they do not have an acceleration. So S is equals to UT, meaning to say this is your speed is equals to distance upon time formula. And you simply put in the values, you plug in the values. 12 centimeter was your distance. Initial velocity, horizontal velocity was 6 into 10 to the power of 7. And time can be worked out as 2 into 10 to the power of -9 seconds. They then ask you for the to calculate the vertical distance. Please note that for projectile motion, the time taken to move the horizontal distance and the vertical distance will remain the same. So S is equals to UT plus half AT squared. For half projectile motion, your initial velocity is considered to be 0. And that is why I have inserted no value here. For half projectile motion, this was a half projectile motion, right? The time is provided to you, acceleration in the vertical component is provided to you, and you'll realize that the displacement is this value. They ask you to calculate the angle to the horizontal at which it emerges. Please note that I have the horizontal speed. My vertical speed initially was 0. However, I can use V is equals to U plus AT to calculate the vertical velocity. So I simply use V is equals to U plus AT. My initial velocity again was 0. A was provided to me. Time was there. I worked out my vertical velocity as this value. Now you need to understand that the electron moved downwards. It was horizontally traveling initially before entering the electric field. And the resultant force, resultant velocity, you could say, can be worked out. Using tan theta is equals to 4 into 10 to the power of 6 divided by 6 into 10 to the power of 6. You can work out that the projectile deviated at an angle of 4 degrees. right? Moving forward, your vertical velocity had acceleration and it started from zero. So v is equals to u plus at. Here u cancels off. Velocity is directly proportional to the time. That is why it is a straight line. In your horizontal velocity component, there was no acceleration, so it travels throughout at a constant velocity value. Moving forward, if they ask you to calculate or to draw a graph for the horizontal kinetic energy and the vertical kinetic energy, so since kinetic energy is directly proportional to the velocity, right? Kinetic energy is equal to half mv squared, and you know for a fact that v squared is equal to u squared plus 2as. Right? Because of the fact that, by the way, initial velocity was zero, so kinetic energy was directly proportional to the displacement. Therefore, kinetic energy against distance graph for the horizontal component stays as it is, whereas for the vertical distance also stays as a translation of the previous part. Because kinetic energy is dependent on the velocity. Does moving forward, they ask you to calculate, they ask you to work of the distance against time graph. Please note that equals to ut plus half at squared. For the horizontal distance, there is no acceleration. So distance speed is equals to distance upon time, right? This can also be written as distance is equals to speed into time, right? This is your y-axis, this is your x-axis. Your gradient would provide you with a value of speed. For the vertical part, s is equals to ut plus half at squared, right? This is a half projectile motion, so your initial velocity is zero. So s is directly proportional to t squared. Displacement is directly proportional to t squared. That graph looks somewhat like this. Time, displacement. Please understand that time cannot be a negative quantity, and that is why the projectile has this graph in here. Next comes in interconversion of energy. Please understand one thing. Say this is my positive plate. Lines will always be positive. For a minute, think of a positive charge that starts off from rest towards the negative plane. When it moves, it started from rest. When it moves, it had gained kinetic energy. Now, please understand that when it is moving along with the field lines, the electric potential energy decreases. That is, the work done by the field decreases. In normal cases, you had two types of energies, kinetic energy and gravitational potential energy. Since in electricity, we do not accommodate gravitational effects. So we are gonna take electrical potential energy and kinetic energy. As opposed to the above case, if a positive particle is made to move towards the positive plate, there is a repulsion. Now think for a second that despite the repulsion, the particle continues to move towards the positive plate. Now the electric potential energy increases, and due to the repulsion, the kinetic energy had to decrease. The reverse case applies to the negative charge. That for a charged particle moving with the field, the kinetic energy will increase, however, the electric potential energy will decrease. For a negative charged particle moving with the field, the reverse case happens, the kinetic energy decreases, however, the electric potential energy increases. For positive against the field, the kinetic energy decreases and the electric potential energy increases. And the reverse happens for that negative charged particle. For any charged particle, this is the key point. For any charged particle moving perpendicular to the field, the change in electric potential energy is zero, or you could say the work done is zero. Alpha particle has 2 protons and 2 neutrons, and it resembles a helium nucleus. Alpha particles are considered to be positive particles because of this fact. Beta particles will resemble a beta particle will resemble an electron, and therefore will have the same mass as an electron and the same charge as an electron. Alpha particle resembled a helium nucleus. Helium has this configuration. This is the charge, and therefore I multiplied charge by 2, whereas my mass is multiplied by the mass of one particle, which is 1.67 into 10 to the power of minus 27. You are provided all of these values in the data booklet. Alpha particle, if made to start off from the positive plate, it will be attracted towards the negative plate, and therefore the kinetic energy increases, the electric potential energy decreases. For the beta particle, the reverse case happens, the kinetic energy decreases, whereas the electrical potential energy increases. Let's say you're asked to calculate the ratio of the acceleration of alpha to the acceleration of beta. Now you know for a fact that F is equals to ma, right? And the force in an electric field can be broken down into EQ, right? Make this entire equation in terms of acceleration, so that makes it EQ upon m, right? So acceleration of alpha upon acceleration of beta, right? E is a constant value. You see charge to mass ratio, right? Acceleration is directly proportional to the charge to mass ratio. Electric field through which both of these particles were accelerated was the same. So that gets cancelled off. Charge of alpha is 2e. Mass of alpha is 4u. Charge of beta is 1e. Mass of beta is this value. When I calculated, this was the ratio. Meaning to say that a beta particle will have an extremely large amount of acceleration when compared with the alpha particle. And this is due to the fact that beta has a very small mass, which made it attain such a great acceleration and hence a very great speed. We move on. As the beta particle travels 20 centimeter in the electric field, its kinetic energy was reduced by 18 kilo electron volt. Now I need you to understand something. Use the information to calculate the electric field strength. Electron volt is an alternate term for energy used for particulate physics or quantum physics. We have the formula voltage is equals to work done upon charge, work done or energy upon charge. Right? Voltage into charge can be equated to work done or energy. It is from this relationship that I can say, that voltage has the unit of volts and this electron has a charge of E, right? And therefore electron volt is an EV, which was equated to energy. Let's say my voltage value was 1 volt. Electron has a charge of 1.6 into 10 to the power of minus 19 coulombs. I can work out from here that 1 EV is equals to 1.6 into 10 to the power of minus 19 joules. Kilo as in you increase the value by 1,000. So 1.6 into 10 to the power minus 16. Mega as in increase the value by 1 into 10 to the power of 6. Right? They told you that the value, the beta particle had lost 18 kilo electron volt. So I will initially convert this 18 electron volt, kilo electron volt into joules, right? 1 kilo electron volt is equals to this value, this amount of joules, and I multiply that by 18 to calculate the total amount of energy, right? This is my total amount of energy, this value right here, right? And from here, you know for a fact that voltage is equals to work done upon charge. Voltage, your work done was this value, charge was this value. You will realize that your voltage value is approximately 18,000 volts. E is equals to V upon D. Your distance was provided to you. Voltage was here. And from here, you can work out that your electric field strength is 90,000 volt per meter. Next comes in the concept of drift velocity. When an electron is made to pass through a conductor, when you apply a potential difference, an electron starts to move in a certain direction. The speed with which it travels is called the drift velocity. The speed or velocity of the electron will start to move in one direction once a potential difference has been applied. Now you need to think for a minute. Let's say I have L as the length of my container, right? A being the cross-sectional area, right? And the charge on the electron is E. since this is a container, definitely there is not just one electron present. There are a large number of electrons present in the container. So N could be the number of electrons present in a unit volume, right? Let's say there were N number of electrons. Like if you pick this value, number of electrons in a unit volume, number of electrons per unit volume can be represented by this ratio. If I had my volume increased by a factor of AL, I will simply multiply that value and therefore multiply that by N as well. Okay, so if I have a total charge, if I were to calculate the total charge, now this is a quantity, certain number of electrons per unit volume present, right? If one electron has a charge of E and that is multiplied by this quantity, I could get the total charge value. You know for a fact that Q is equals to IT, that Q is the total charge and can be replaced by this quantity, right? Time is distance upon speed. Speed is equals to distance upon time. So I'm just replacing the terms. I'm converting it into distance upon speed. Right? Please understand that L is the distance I am looking for because the electron travels in this direction and not perpendicular to the conductor. Therefore, the distance is replaced by L. The L and L cancels off. The speed with which the electron are taken off was V, and V is called the drift velocity. Rearranging the formula, I get somewhat I is equals to NAVE, where the drift velocity of the electron is directly proportional to the current. It is inversely proportional to the area. The charge of the electron, and the number of electrons per unit volume stay constant. So I will not consider those two factors. Let's say, for example, if I had a conductor, the conductor had its cross-sectional area decreasing such that initially X had a diameter of 2D and Y had a diameter of D. They gave you the diameter ratio as 2/1. They're asking you what will be the ratio of the drift velocity. So they want the drift velocity of Vx upon Vy. Now you know for a fact that drift velocity is inversely proportional to the area, and area is dependent on diameter. Right? You know for a fact that area is equals to pi d square upon 4. So from here you can say that area is directly proportional to d squared. These two are constants, so I'm not considering them. Right? Simply square these values and you'll realize that the area ratio of X to Y would be 4/1. So drift velocity value, because it is inverse, Vx upon Vy should be 1/4.
Yes,
Moving
sir.
forward, let's say I have a circuit. There was a resistor X, there was a resistor Y. Now from you need to understand something, that the resistor is made of the same material, meaning to say that the resistivity is the same. the number of charged particles per unit volume is the same. They're asking you for the ratio of drift velocity in X to drift velocity of Y. Right? Drift velocity, you know for a fact that I is equal to NA V E. Right? So drift velocity is equal to I upon NA E. E is the charge of the electron, somewhat like this. Right? N and N are the same values, so they simply cancel off. N and N will cancel off. You need to understand that this is a series circuit, and in series circuit, the current stays the same as well. So that also cancels off. Charge of the electron is also constant. So again, drift velocity of X upon drift velocity of Y is equals to AY upon AX. Diameter of Y was 2D, square it off, that becomes 4A. Diameter of A was 1D, square it off, it becomes 1A. And when the area ratio for X to Y was 1 upon 4, drift velocity of X to Y would be inverse of this, which is 4 upon 1.